So welcome again, guys. Now we're gonna be talking about pressure in solids. Now pressure in solids is defined by the force per unit area. Okay, you could also calculate the force, which is equal to the pressure times area, or the area is equal to the force divided by the pressure. Okay, so as you could see from this law, force over area, this means that pressure is inversely proportional to the area. The greater the area, the smaller the pressure. The smaller the area, the greater the pressure. Now, this is what we're going to be discussing in this lesson. Now, pressure is measured in a unit that is called Pascal, which stands to Newton per meter square, because the force is measured in Newton and the area should be measured in meter square. This also could happen, and the force could be also in Newton, but the area is in centimeter square. Now that is different. Now let's look at these examples. Now you've got the 50 is acting at a certain area of 2 meter square. You calculate the pressure is 25 Newton per meter square, which is Pascal, 25 Pascal. But in this case, you've got the area in centimeters square. So if you calculate the pressure force over area, it is 50 Newton per centimeter square. That is not Pascal, that is just a unit of pressure. Okay, keep that in mind. So let's dive into a different idea. Here you've got this concrete block and it's laid over in a different position in every time. So the force is 24 Newton of this block, and this time the area is 6. How could I get the area 6? As you could see, this is the area resting, right? And the block has got a weight of 24 newtons. Keep in mind, he could not give you the weight, he could give you the mass. So if the mass was given as 2.4 kilograms, you'd have to multiply this by 9.8, which is rounded here to 10, and therefore you could get the force. So given that, so you've got the force is 24, the area is 6, so the pressure is 4 Pascal. Okay, in this case, you've got the block laid down on the bigger area, so 3 times 4, that's the area. The weight is still the same, which is 24. It gives you a smaller pressure. So that's what we said, pressure and area are inversely proportional. When we increase the area, the pressure decreased. Okay, these are more examples about force and pressure and area. If you're trying to walk on grass wearing a stiletto or high heels, or wearing sneakers or a trainer, which one is easier? Of course, as a trainer's got greater area, so therefore you can walk easily on grass or sand. Okay, in this case, so you've got this pen where you can stick to the wall, you can stick things to it. So if you got a certain force at this point, so it's the same force that travels to this area, but at this part, this is area 1 and this is area 2. So in area 1, the force is gonna act upon this area 1. So pressure is equal to force over area 1, which is gonna be a smaller pressure than the one created with force and area 2. So this is why the pin's got higher pressure at this point, and you can stick it to the wall, or you can use it on anything that you want to stick it to. Okay, so the main idea, force acting on a small area gives you high pressure. Force acting on a large area gives you a low pressure. Okay, thank you for watching.